Hey students, it's me, Mr. Fitz. So today we're gonna study some triangle congruence theorems, and I'm wearing my congruent triangle sunglasses just for that. So let's take a look. Here we go. So, oh, by the way, it's a kind of funny Pythagorean theorem joke, right? Please don't answer a Pythagorean theorem question like this on your test. Yeah, anyway. So, triangle congruence theorems, that's what we're gonna study today. And first of all, we need to know the definition of congruent. So please write this down on your notes. Congruent means identical in size and shape. So we looked at this already in class, right? Because we looked at, geometric transformations. So if we think about like this transformation here, this looks like some sort of translation in the plane. So yeah, that's just a one-to-one mapping of points. So A gets mapped onto D, and B gets mapped onto E, and C gets mapped onto F, right? So it could have been a rotation or a reflection. They are going to be congruent figures. Can't be a dilation because that wouldn't be identical in size. All right, so if we know that, the one thing we need to remember is our correspondence, and this is new. So if we're going to think about our correspondence, what I'm going to do is going to write my congruent statement. And so if they've told us that this is a translation, then we can say, given triangle ABC is congruent to triangle DEF, and we should probably talk about some symbols, right? So you might want to write these down. So this symbol here, the equal sign with a little squiggly on top, means congruent. This means angle. These three dots mean therefore, and then if you see a triangle, that just means triangle. So you're going to see a lot of symbols this year, so you want to make sure you take note of what they mean. All right, so what I always do when I see a triangle congruence statement is I stack my letters because that's going to show me my correspondence. And this is super important. Please do this every single time. Trust me, it will make your life simpler all year. It takes 2 seconds. Stack your letters. So this shows me that A corresponds to D, B corresponds to E, and C corresponds to F. This is my map. So A gets mapped to D, B gets mapped to E, and C gets mapped to F. So given that, I know there's 6 parts to triangles, right? There are 3 sides and 3 angles. So if I know that information and I have this correspondence statement, what I can then conclude, therefore, that's what the 3 dots mean, and I'm going to go ahead and use my map here. Angle A is congruent to angle D. Angle B is congruent to angle E, and angle C is congruent to angle F. So right now, basically, we've done a proof, right? Like they've given me some triangle congruence things, and I'm able to prove other things. I know that the corresponding parts of the triangle are congruent because the triangles are congruent. So I'm going to go ahead and mark my diagram. So I'm going to use these little like angle markings with little like whiskers almost. So angle A is angle congruent to angle D. You mark that with the one line. B is congruent to E. I mark that with little 2 dashes there. And C is congruent to F, and I mark that with 3. Okay, let's take a look at the other things we can prove. So I know that the angles are congruent. I can also say that the side lengths are congruent. And by the way, if you see 2 points with a little bar on top, that means line segment. So that's saying side AB, or line segment AB, is congruent to line segment DE. So AB is congruent to DE. How did I figure that out? Well, look, AB is above DE. So AB maps to DE. Super easy. For this diagram, you're probably like, oh, that's super easy. But imagine if this is something where rotated or reflected. It's really, really difficult. So make sure you do this. Also, I know BC is congruent to EF, right? BC is congruent to EF. And then AC is congruent to DF. And then I marked my diagram here with these little like whisker things too. So AB is congruent to DE. CB is congruent to FE, or I could say BC and EF. And then AC and DF. There you go. And remember, you can list a line segment in either order. So I could call this EF or FE. But make sure you're going to list them in the same order. So if I said A, B, and DE, or I could say BE and ED, BA and ED, right? So make sure you list it in the proper order. Super important that we're precise. Okay, there we go. That is how correspondence works. Now, what we want to look at, you don't need to prove all 6 things are congruent to prove triangles are congruent. And this is going to be super useful for us for all year. So I can prove triangles are congruent if I know three things. And so these are like shortcuts. So spoiler alert, here we go. These are the ways we can prove triangles are congruent. Side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. These are the ways we can do that. And so I'm going to go through each of these and I'm going to show you some examples in a little bit. So side, 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 if three sides of one triangle are congruent to three sides of another triangle, the triangles are congruent. And then it has this other thing written here. It says, for this method, the sum of the lengths of any two sides must be greater than the length of the third side to guarantee a triangle exists. That is our inequality theorem, right? We already learned that. We learned that in the previous video. So side, 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 if I know that three sides are the same length, there's no other way for me to piece those three sides together. If I have three sides, it has to be that triangle. I can't piece it together any other way. Okay, that's the first one. Side, angle, side. If two sides and the included angle of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. The included angle is the angle formed by the sides being used. All that means is that the angle is connected to the sides. So I like side, angle, side. I always think about like the peace sign. How that works is if I have two sides, right, and an angle in between them, there's only one way for me to piece together a triangle. Like there's only one side length that will fit this third side. So if I know two sides and the included angle, it doesn't matter where that goes, that's going to be the same triangle. I can't draw a different triangle because of that. Okay. Next one, angle, side, angle. If two angles and the included side of one triangle are congruent to the corresponding parts of another triangle, the triangles are congruent. What that means, oh, and then it also says the included side is the side between the angles being used. That means the angles are connected to the side. So think of it as like a sandwich, right? The angles are a sandwich, and the angles of the bread, and the side is in between the two angles. So angle, side, angle works. The next one is angle, angle, side. If I know two angles on a side, the triangles are going to be congruent. It's just like they're two different ones. So basically you mix up angle, side, angle, and angle, side. It's not the end of the world, but it is nice to distinguish between the two. You can always prove that they're congruent. So basically, if this side is like not sandwiched between the two angles, then that's angle, angle, side. So I kind of like always go around the shape. Like I think about like angle, angle, side. And then this is like angle, side, angle. So those are the slight differences there. And that means the side is connected to one angle. So these two work. So all of these work. And then hypotenuse leg is a special case if you have a right triangle and you know the hypotenuses, I don't know. The hypotenuses are congruent and one of the legs are congruent. So we talked about that last video too, right? What's the leg and what's the hypotenuse? And if you have a right angle. So if it's a right triangle and you know the hypotenuse and the leg, then you also know they're congruent. And by Pythagorean theorem, if you know two of the sides, you can prove the third side, right, with Pythagorean theorem. So it's really just, you could take the next step and use side, 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 right? So anyway, there we go. So we're going to look at some examples. So let's take a look. First one, side, side, side. So if I have these two triangles and they're marked like this, so like this side is congruent to this side is congruent to this side, and this side is congruent to this side, then it's side, side, side. There you go. Easy peasy, right? All right, let's take a look at another set of triangles. Yeah, this one here, we have two triangles. They're congruent to each other. And this is going to be side, angle, side, right? They have two sides and an included angle. Happens to be a right angle. That's fine. Two sides and an angle. If I know two sides, then an included angle, then it has to be side, angle, side. There you go. What's the next one? Angle, side, angle, right? So like take a look here. We have an angle, an included side, meaning the side is sandwiched between the two angles. That's going to be angle, side, angle. All right, one more. Whoop, I miswrote that, didn't I? Let me fix that. See, even I mix these up sometimes. So this is going to be angle, angle, side. So angle, angle, side, right? I have two angles and the side is only connected to one of them. So it's like angle, angle, side, angle, angle, side. Sometimes people call it side angle, angle. That's fine. You could call it side angle, angle, or SAA. That's fine. Okay, let's look at one more. Wait, what? Hold on. This is angle, side, side. ASS, that wasn't on my list. And I shouldn't be writing this, right? That's no cursing in geometry, right? So actually, angle, side, side, or side, side, angle does not work. We do not curse in our geometry class. No, 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 no. Remember, it's the Disney Channel. We're not going to be using that type of language in our class. So no, 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 nope, nope. Never use side, side, angle, or angle, side, side. Yep, nope. Side, side, angle is ass backwards. Okay. All right. Angle, angle, angle also does not work. Reason? That could be a dilation. It could be bigger or smaller, right? And contain the same angles. So that doesn't work either. What about this one? This looks like angle, side, side again. We said there was no cursing in geometry, right? But, well, since we don't want to curse in geometry, we're going to rewrite this because this is a right triangle. And if it's a right triangle, we could say the hypotenuses are congruent, right? And the leg, this one leg, are congruent. So we can say this is hypotenuse leg. Again, because of Pythagorean theorem, you can actually figure out the third side. So you don't have to worry about cursing. So that is not side, side, angle, or angle, side, side. That is actually hypotenuse leg. Okay, there are examples. And so you're going to get plenty of practice with this. If you have any questions, please let me know. And thank you so much for watching. Okay, let's play a name of that tune, actually. I don't know. I can't play for too long because I might get copyrighted. Can you name that tune? Good luck.